All right, we're back. Question 7 here in our series on tricky A-level maths exam questions. As we can see here, we have a question on differentiation from first principles, which is normally pretty straightforward and for the most part not too challenging. However, this question here, as we can see then, is a pretty good challenge, right? So what I would recommend here is pause the video now, have a quick go at the question, see if you can, derive this result here from first principles. You know what you need to get, so you have a good idea of whether you got it right or wrong. You should definitely know whether you've got it right or wrong. If you're not too sure, resume the video and we'll take a look at it together. If you'd like to have a go at other questions such as this one and even more challenging A-level maths and A-level further maths exam questions, be sure to visit our website, AJMaths.co.uk. We have hundreds of questions and worksheets already available, and also members videos and even mock exam papers. So there's plenty of revision and additional resources for those who need that extra push, right? So let's just get started then with today's question, question 7. So what we're given here is f of x, right? So f of x is equal to 1 over x. And we want to prove then from first principles that the derivative of f of x is the following. So this is a standard result, right? And even if you're not aware of this result here, you can just easily derive this yourself. Now, how do we derive this from first principles? That's where the challenge lies here. Now, what I've also included here, and this is given in your formula book, right, is the relevant result here for differentiation from first principles. It's given in your formula book, so not something that you do need to worry about memorizing, but it is pretty straightforward for the most part to kind of memorize this result here. So f prime of x then is equal to the limit here, as h tends to 0, of f of x plus h minus f of x all over h, right? And we simply need to use this result here. So whenever I have a question on differentiation from first principles, I always just start then by stating f of x, which we're already given here. So f of x then, that's just simply 1 over x. And what I also want here is f of x plus h, right? So f of x plus h. So f of x plus h, then that would simply be 1 all over x plus h. Perfect, okay? And at this point here, we now have everything that we need then to find or prove this result here from first principles, okay? So therefore then, f prime of x here is equal to the limit. So it's the limit as h tends to 0 of f of x plus h, that's 1 over x plus h. So 1 all over x plus h minus f of x, which is 1 over x. It's minus 1 over x here. And that's all over then h, okay? Right, so where do we go from here? Now, this is where this question starts to get a little bit challenging. More than anything, it is the algebra that's involved with this question here and simplifying to get to the desired result, okay? So what I'm going to do here is just start with the numerator here. There's nothing else I can really do, right? And what I want to do here is just get this over a common denominator. So again, we do need to write down the limit each and every time here. I promise it gets really tedious, but you do need to do this. It is important. Don't neglect this. So the limit as h tends to 0 of then, so getting this over a common denominator here, what we're going to get then is I'm going to get x because I need to times this one here, this fraction by x. I need to times this fraction here by x plus h, right? So I'm going to get x then minus here. So 1 times x plus h. So I get minus then x plus h. And that's all over x times x plus h, right? That there gives us our common denominator. And this here is all over h, right? Perfect. So what I can now do here is actually just simplify the numerator. So this x here cancels with this x here because it's x minus x. So they just cancel. What I get then is the limit here as h tends to 0 again. It is really tedious, I promise you. I know how bad this is, but you just need to do it each and every time of minus h then. So we get minus h here all over x times x plus h. So x times x plus h. And that's all over h, okay? Now, if I've got a fraction here divided by this here, this is just the same then as, let's do it on the same line here. So the limit as h tends to 0 of the following. So I've got minus h all over x times x plus h. Just extend that fraction line a little bit there, like so. And if we're dividing by h, that's just the same as times it by 1 over h, right? So we times by 1 over h, just like this. Now, at this stage here, you could have just cancelled by the h's, right? That is what's actually happening here. But for a lot of students, they struggle to see that connection. And I think it's just easier if you write this out as a product, right? Just like this here, because at this point here, it's really obvious and really clear that what's going to happen is this h here will just cancel with this h here, right? And then just multiplying across here, what we get then is the limit. We get the limit here as h tends to 0 of, so I get minus 1 then all over x times x plus h. Now, to make my life a little bit easier here as well, what I'm also going to do then is just multiply or expand this bracket here, I should say. So I'm going to get minus then, so minus 1 all over x squared times, x squared plus xh. There we go. I can't do basic math. So there we go. X squared plus xh. There we go. Perfect. Just like this, right? And at this point here, all we now need to consider then is just the behavior of the limit, right? So what's going to happen here as h tends to 0? So now take the limit. So now take the limit. So now take the limit as h tends to 0. So obviously there's no h's here with the x squared, so nothing will happen to that. But for the xh here, if h tends to 0, so in other words, h gets really, really small, then xh will just become 0, right? Again, that will become really, really small. So as h tends to 0, xh also tends to 0, right? And what I get left with then is f prime of x. So we get f prime of x here is equal to minus 1 all over x squared, exactly as we require, right? As we can see here, we wanted to prove from first principles that the derivative of f of x is this here. And we've arrived at the exact same result, right? Because this part here basically just disappears. You can think of it as just cancelling out. So we just get left with minus 1 over x squared, right? And that's once we take the limit as h tends to 0. This part here also tends to 0, right? And there we go then. So we get f prime of x here is equal to minus 1 over x squared as required. Perfect. Okay. QED, give it a tick, whatever makes you happy. There you go. That's your solution, right? And there we have it then. So hopefully, this question here was a good example of a more tricky differentiation from first principles question. And like I said, if you'd like to have a go at even more questions, just like this one here, more challenging differentiation from first principles and just general A-level maths questions, go and visit our website, ajmaths.co.uk. We have tons of additional questions and worksheets available. But there we have it then. So that gives the solution here to question 7 in our tricky A-level maths exam question series. And that brings us to the end of this video here. As always, thank you for watching.